Some of the most common mistakes we make whilst writing JavaScript code is to misspell a property or a method name. And we only find out about the mistake when we get a runtime error. That is to say, when we are running our application. And this is why testing is so important for JavaScript applications. Only running a JavaScript application actually can surface errors. In other languages like C++ or Java, we have something called type checking. And during a compilation phase, it first checks for some simple mistakes in the code and raises an error if it finds any. TypeScript's transpilation mechanism also performs type checking. However, it only works when we tell TypeScript the type of things. So in JavaScript, we might write something like so let A. So we expected the type of the A variable to be a number. We expected it to remain a number over the life of the A variable. But by mistake, we assigned a string 2 to the A variable instead of the number 2. And in JavaScript, this doesn't actually cause an error. And only if one of the functions which we use, which depend on the variable A, starts misbehaving when we're running our application, do we even get a clue that something might be wrong. However, with TypeScript, we can clearly state that we want the A variable to always hold a number, like so. So then if we compile our TypeScript file, I'm going to compile by using the -watch flag. It then gives us the error that type string is not assignable to type number. We've declared on line 1 that the variable A can only ever hold numbers, and we're trying to assign it a string on line 3, and TypeScript is saying that's not right. There's probably a problem here. So what are the different types that we can have in TypeScript? I'm going to copy and paste them to the screen. So we can have the number type, which can only hold numbers or floating point numbers. We can have the Boolean type, which can only hold the true or false statement. And then we can have the string type, which can hold any string. For arrays, we have two ways of describing the types of arrays. The first is to use the brackets notation, like so. So I've declared a variable called list. It will hold an array. That's what the brackets mean, an array. And each element in the array will be a number. So making it hold 1, 2, 3 as an array of numbers is fine. If I then changed the 3 to a string, watch the terminal screen at the bottom. So now we get an error. So it's complaining because we tried to assign one of the elements as a string, whereas they should always contain numbers. And the second method is to use something called a generic type, which I'll just paste in here. So we're saying it's an array, and the array will hold numbers with this special angle bracket syntax. And this is a generic, and we'll cover generics in more detail later on in this lecture. We can also describe a variable as one that will only point to a function, like so. So fun is a variable, and we're saying the type of that variable is function. So this fun variable will only ever hold another function. So this is an anonymous function here. And because we're getting the error at the bottom saying cannot redeclare block scope variable list, that's happening because we've declared list twice on 5 and 6. So let's get rid of one of them. And now, yep, our compilation is fine. And sticking to the topic of functions, with TypeScript we can also define the expected return type of a function. So this is saying that the return number function, I'm saying that can only ever return a number. And if by accident through my code I try and make it return a string instead, this gives us an error. So in ES6 we have a new data type. It's called an enum. and it consists of a set of named values. And the names are usually identifiers that behave as constants. So let me create an enum for direction. And then I create a variable called go, and I'm saying that that variable can only ever hold one of the types of the enums. So if I say go is equal to so if I assign to go direction.up, that's perfectly valid. If I then try to assign it something else like a string, it's going to complain of an error. So classes and interfaces, whether created by you or others, are also types of things. So we can use them where we would use any of the other built-in types. So here I've defined a class of person, and I've said that the variable person can only hold an instance of that person class. And I've also said the variable people can only hold instances of person. So there's also the any type. If we don't know the type of something, we can also fall back to using the any type. If used, it doesn't provide any type checking, but does make it clear that we intentionally don't know the type, rather than we forgot to add the type. So I create the variable not sure, and I say, well, that's any type. I'm not really too sure what that will hold. And then later on, if I try and make not sure hold a string, if we look at the terminal at the bottom, that's absolutely fine, because we've said that not sure can hold anything. It can hold numbers, or it can hold strings, or whatever else we want it to hold. There's also another type called void, and void means no type. It's typically used to indicate that a function will not return anything at all. So if I create a function called return nothing, it's got void, I'm just logging in this function, it's not returning anything, then that's fine. If I try and return something from this function, it will report an error. So sometimes we end up in a situation where we know more than TypeScript about the type of something. In those situations, we can use something called a type assertion as a hint to the transpiler about the type of something. So let's say we have a variable called value, the type is any, and I've made it point to a string. I then want to call value.length, which is a function that's available for strings. I can then give a hint to TypeScript, and I can say, so I type angle bracket, string, close angle bracket, and then the name of the value, and I wrap the whole thing in round brackets. And this hints to the TypeScript transpiler that I know that value is a string, and therefore, because it's a string, it has the length function. This is what we call in TypeScript a type assertion. Okay, now let's talk about generics. How can we create reusable bits of code which can still take advantage of TypeScript's transpile time type checking? Take, for example, this. I have a post that has some content. The content can be some audio, some video, a link, or some text. And the content will just be an instance of audio, video, link, or text. Therefore, what do we set the type of content? Well, for now, I've set it to any. And because it's set to any, it means that TypeScript can't perform any type checking. It can't check to see if we're trying to assign something to content that isn't one of audio, video, link, or text. What we could do is we can create separate audio post, video post, link post, and text post types like so. So we could just create a bunch of individual types, one for each different type of post, and we then set up the type specifically, explicitly for the content in each of those types of posts. But apart from being just really verbose and time consuming, it also assumes we know all the content types up front. maybe somebody who's going to use our post class later on would like to create a post, a VR, a virtual reality post type. But with generics, we can dynamically generate a new type by passing into the post type a type variable. So deleting these and going back up to our post type, I can pass into my post class a type using the angled brackets, and then we can use T wherever we would use a type. So I'm going to use T as the type of content. Now we can actually call it whatever we want. We could call it asim. But the convention is to call it T for type. And then finally, when we want to create a specific type of post, we just declare it like so. So let video post video. So this variable video post will hold an instance of a post whose content property holds a video. And if you try to make it hold anything else, it would throw an error. By default, we don't have to add types when using TypeScript. We could just leave them out. So if I typed, let me get rid of this, it's causing some errors at the bottom. Those errors are just because we've already declared some classes in another file with audio, video, link, and text. So it's complaining that it's seeing the same identifier. But if I type let answer and then answer equals 42, TypeScript won't perform any type checking because it just assumes a type of any. If we don't provide a type when we declare a variable, it just assumes it's any. It just assumes it's this. Now this behavior is controlled by something called the no implicit any flag in the tsconfig file. So if I open up tsconfig, you can see we've got the no implicit any flag. Now this is set to false. When it's set to false, then TypeScript assumes any for missing types. If we set it to true, then TypeScript throws an error if no type is present. So here we go. So now it's saying variable answer implicitly has an any type, and that's an error. If I go back into types and I give it a type, and even if I give it the any type, it's fine. It's happy for me to give it the any type, but I must give it some type. So opinion is split as to whether we should keep this property, this configuration variable, set to true or false. And by default, it's false. And false is just far more forgiving. But by being forgiving, it doesn't force developers to use types, which is the point of TypeScript. If a variable is declared and initialized on one line, TypeScript will try to guess the type of a variable by how it's declared. So for instance, if I actually wrote let answer equals 42, then TypeScript will determine that the type of answer is actually number because it's being assigned a number as soon as it's being declared. So then later on, if I type answer is equal to the string 42, this now returns an error. So even though we didn't explicitly give answer the type of number, because we assigned it a number when we declared it, TypeScript inferred the type of number. So this is all fine for code that's written in TypeScript and has types. What if you wanted to use code that wasn't written in TypeScript, or which you are not going to include as TypeScript and compile yourself? So to use other code that doesn't have types and that isn't written in TypeScript in our TypeScript code and still perform type checking, we can use something called an ambient type definition. This is a file that contains metadata about the types in another library, a meta type file. If you look in GitHub, there is a repository called Definitely Typed, and this contains type definitions for some of the most popular third-party libraries. So, for example, if you look in, FileSaver, you'll see there's a file called filesaver.d d.ts. That is the type definition file. And in here, it's just a description of the types in that library. So to use them, what we need to do is basically download the .d.ts file, store it somewhere in our code, and then in our TypeScript code. So let's imagine we were doing this for jQuery. So to use them, what we do is in the top of our TypeScript files, we do \\\\, reference, and then the path to the type definition file that we've downloaded. And we can have multiple ones that we can just have like that on the top of our file. So that's all a bit cumbersome. So there is also a command line tool you can use called typings, which handles the legwork for you. We install it via npm. So we type npm install -g and then typings. Then we can install type definition files using the typings command line. For instance, if you wanted to install the jQuery type definition file, we would type this. So typings install jQuery --save, saves it to our typings.json file. We're saying the source is a definitely typed GitHub repo, and global is just saying that we want to install it globally. And now once that's installed, if we look at typings, we can then see our jQuery is defined there. But also we'll see a folder created called typings. And if we open it up, inside global, we'll find our jQuery type definition file. And then it conveniently bundles all of the downloaded type definition files into one file, into an index.d.ts. So this has a reference path to global jQuery index.d.ts. So then to use jQuery with TypeScript support, we just need to add a reference to our index.d.ts to the top of the file. So if we go back to our types, we would then just type typings index.d.ts. And remember, it just bundles everything together. So if we added another one, let's say we add Ionic. If we then look in the globals, we'll find Ionic and jQuery, and we'll find both in that index.d.ts. So then in our types.ts, we only still need to just include that one file because everything that we've installed via typings is just getting bundled into that one file anyway. So in summary, with transpile time type checking, TypeScript can help uncover bugs much earlier and faster than if you were trying to manifest those issues at runtime. Using types is optional but highly recommended by the Angular team. If using third-party libraries that have already been transpiled into JavaScript, TypeScript can still perform transpile time type checking if we include the type definition file for the library.